Continue. Um, Today we're talking about torque, and that will tie together some things we've talked about already, and maybe a couple of new concepts that aren't scary. They just sound different, and there's more Greek letters coming your way. But we'll talk about torque today. And I have made the decision that we're not going to have class on Friday. I don't know how you're doing. I am really struggling these days. I don't know what exactly is wrong. There's nothing more going on than usual, but I think mostly I have a few things that I have to do that I haven't gotten done, and I just can't bring myself to do them, and I'm getting more and more behind and feeling crummy. So I am taking a personal day on Friday, and we won't have class. And I hope if you are struggling, if the end of the semester is maybe bumming you out, if you have a lot of stuff due soon and you can't imagine how you're going to get it all done, maybe take that 75 minutes when we would have been meeting on Friday and get something done. It's a lot at the end of the semester, and I feel it. Unfortunately, like all professors feel it, and some people are grumpy about it, and other people kind of keep it together a little bit better. But you know, if you find people being a little short-tempered, try to have some patience. If you're feeling short-tempered, try to, you know, count to 10 and relax. But there's just a lot going on right now, and we'll get through it, and we'll get through the end of the semester, and all will be well. Let me just share with you. I gotta find the thing again. Share screen. I'm doing this not to freak you out, but just to orient ourselves. So just so you know, hopefully you're keeping up in lab. I will communicate with Professor Logston sometime soon to see where he stands with grading and all, just to keep you informed on lab. Lab generally brings your overall course grade up and not down, but you know, if you've missed a bunch of labs, that can be terrible. We've had exam 1, exam 2 is coming up very soon. And then once I put together your homework, your quizzes, your lab, your 2 exams, you will have a sense of where you are. If you already have an A, which in my class is a 92 or higher, then you don't have to take the final. But if you do choose to take the final, that final exam can replace whichever exam score is lower from exams 1 and 2. And I will explain what I'm going to say right now a couple of times, and people will still be freaked out by it. But after you take exam number 2, I'm going to go ahead and take the lower score that you have from exam 1 or 2 and put it in place of your final exam. And that will let you know what grade you would have if I double counted your lowest score. And then if you take the final exam, I'll replace that and the lower score with what you got. Maybe I won't do that because that just confuses people. But the idea is just to say a big boost in your grade. Anyways, homework is 10%. If your homework is not 100%, you can make it 100% by going back and doing those problems till you have them correct. Quizzes are 15% of the grade, and I will drop your lowest quiz score. I don't have the system set up for that just yet, but I will do that. Lab is 15%, exam 1, exam 2, final exam. So 40% of your final grade can be what you get on the final exam. And the final exam is selected questions from exams 1 and 2. So you can watch the exam key videos, go through each problem, remember exactly how to solve those specific problems. And out of those problems that we had on exams 1 and 2, there will be probably 5 or 6 from each of those exams on the final. So you know what group of questions to study from. Oh, come on, I thought this had the schedule in here. Oh, here, sorry, I'm losing my mind again. So here we are. Wednesday, April 14th, we will cover chapter 9. On Friday, we will not have the quiz on chapter 8. Next Friday, April 23rd, I will answer any questions from chapters 8 and 9 homework, and we will have a quiz covering both chapters 8 and 9 material. Next Wednesday, April 21st, we will cover chapter 10, and that is the last of the new material in this course. So then the following week, Wednesday, I will be fielding any questions you have from the practice exam. And if you don't have questions, I will pretend that you did and you private chatted me, and I'll go over some things that I think are important. But it's so much better if you actually have questions and I'm answering those.
So
and then, yep.
Are we not having the quiz on Friday, or I'm confused?
Right, we're not having class on Friday.
Okay.
So no quiz this Friday.
Okay.
And then on Friday, April 30th, we have exam 2 on chapters 6 through 10. When we come back in the month of May, Wednesday, May 5th, I will be available. I'll be here in class time. It's the last day of classes, and I will go over any questions you have from exams 1 and 2 in preparation for the final exam. So if there's some question that you're like, dang, I got this wrong and I don't know why, can you help me figure it out? I will do that. And then I don't have power over when the final exam is scheduled. It's based on when our class meets, so they can schedule final exams so that they're not all on the same day and not all at the same time and all of that. So for any classes that meet Wednesday and Friday at 10:50, the final exam is scheduled for Thursday, May 13th at 8 o'clock in the morning. It's not my fault, I didn't do it, but that is when I will be here on our class Zoom to give hints, explain questions if you have any questions. That's when our final exam time is scheduled. If you choose to do it a different time than that, I won't stop you. There may be a time when I open the exam. I'll have to think about that if I open it earlier, but that's when we'll be here in class doing it.
Excuse me, Professor.
Yes.
I have a question about exam 2.
Okay.
Do we get just one attempt, or do we get 2 attempts on exam 2?
2 attempts on exam 2.
Okay,
So,
thank you.
Sure thing.
Yeah, well, about the final exam, I know you already explained this already, but what conditions would we have to meet, like, to not take it? Like, if we have like a good grade, or like if we didn't take it, would it negatively impact it?
Yeah, that's where you catch me in my plans. So my dream is that everybody wants to get as high a grade as they possibly can in the class. And this semester, it's not pass, no pass. You can choose one class to do pass, fail, and otherwise you get your grades in all of your classes. So it is my dream that the only reason that you wouldn't take the final exam is because you already had an A in the class and that the final exam couldn't possibly bring your grade any higher. That being said, if you, you know, have an awful night's sleep or bang your head or forget everything you ever learned in physics and you do terrible on the final exam, I'm going to pretend it didn't happen and I won't include it in your score. So the final exam can only bring your grade up. It cannot bring your grade down. If you know, wake up on the day of the final exam, or perhaps don't wake up on the day of the final exam because the exam is scheduled at 8 in the morning, and you're like, man, I've got other exams, I can't possibly think about doing this now. If your grade's a C+ before the final, it'll be a C+ after the final. I won't bring your grade down because you didn't do it, but I would love for you to do it and bring your grade higher if that is possible. And it should be possible.
Thank you.
Professor,
Yep.
just to clarify, so the first exam, the second exam, and the final exam, you're going to keep the 2 higher grades and factor those into our final grade for the class?
So exam 1, exam 2, and then I will replace whichever of those scores is lower with what you get on the final, and you will have the final exam score there for the final. So the final exam, you do really well, it can make a huge impact on your grade in the class. Does that make sense?
Thank you.
Sure thing. Okay. So we are not meeting for class on Friday. You don't have to let me know if you're not going to take the final, but it's kind of nice to hear from people. Like you know, if you're always there taking quizzes and exams and then you're not there on the final exam day and you don't have an A, I'd be worried if you know, missed the schedule or something. So if you let me know, that would be nice. I just want to confirm we are not meeting for class on Friday. So I want you to acknowledge that you understand that we're not meeting for class on Friday so you don't panic when I'm not here. It is a weird thing and I don't judge anybody by it, but I have our class meetings set to start recording automatically. So I don't forget, but then I wind up stopping that recording while I'm doing the, you know, 15 or 20 or 30 minutes before class with the slide and the music. So then I start recording again. But when people log in for class and then realize that it's not class that day and log out, I see, you know, that there's a Zoom recording because it records automatically. And every now and then, like I totally relate. Every now and then I'll, you know, get a notice that there's a Zoom recording on a Tuesday at 10:50 because somebody just lost track of what day of the week it was. And I think we all are familiar with that concept in the days of COVID that you just lose track of what day of the week it is. All right, so we all know that we don't have class on Friday. People who aren't here, I did send an email and maybe I'll post some sort of notification because I'm working on Friday. I have a bunch of meetings scheduled still, but taking a personal day and we're just not having class. So I hope you can use those 75 minutes productively to catch up on something that you've been putting off or something else. But that's the plan for this Friday. Okay.
Excuse me, Professor, one more question,
Yeah.
I'm sorry.
No worries.
So regarding the quiz on chapter 8 and 9, next
Yep.
Friday, not this Friday. So is it gonna be a much longer quiz because it's on 2 chapters? And are we still getting 2 attempts on it?
Still 2 attempts. How can I go back to? Oh, come on. For whatever reason, in the fall semester, I wound up doing this same thing where we had a day off in, whatever week this is, week 11 or something. And I did the quiz on 2 chapters. And so when I copied the Canvas course over, that's how things were set up. And so part of the reason for me doing this is that, it was easier because the quiz on 2 chapters was already prepared. I'm looking up the quiz right now so I can tell you there are 6 questions on the quiz. So that's maybe a normal length with, one of the questions be show your work. So yeah, there's 5 questions. Looks like 3 from chapter 8 and 2 from chapter 9. Very similar to the homework questions on chapters 8 and 9.
Thank you.
Okay. So everything gets messy on the page here. Annotate. So in the world of rotational motion, everything has an analog to linear motion, an analogy to linear motion. So in linear motion, we have displacement x in meters. We have velocity in meters per second, and we have acceleration in meters per second squared. And we put all of those things together into the equations of kinematics. For rotational motion, we've already kind of covered that in rotational motion, we talk about an angle, theta, in radians, which is somehow related to how many times something spins around, a quarter time around, 10 times around, 20 times around. But we can describe that moving around in a circle with radians as our angular distance. And then we did a little bit with omega, radians per second, as the angular velocity. And there's another thing, alpha, radians per second squared, which is angular acceleration. It's the change in angular velocity over time. So alpha equals the change in omega divided by the change in time, just like acceleration and is change in velocity over change in time. Now, when we did linear motion, we had our equations of kinematics. don't want to get those wrong because that would be horribly embarrassing. So I'll look at an old data sheet that I have sitting here on my kitchen table. And remember, I'm not asking you to memorize the equations of kinematics. I'm just asking you to know how to use them and solve them algebraically for whatever we're looking for. V equals V naught plus AT is one of our equations of kinematics. X equals 1/2 V naught plus V times time. That's the average velocity times time. So we kind of knew this equation already. Distance equals average velocity times time. X equals V naught T plus 1/2 AT squared. And then V squared equals V naught squared plus 2AX. Those are the 4 equations of kinematics. And if we know 3 of the values in a kinematics problem, we can solve for the missing one in any given situation for constant acceleration. For rotational motion, using these variables, so V is omega. Omega equals omega naught plus alpha t. And theta equals 1/2 omega naught plus omega times time. And theta equals omega naught t plus 1/2 alpha t squared. And then finally, the most impressive looking one, do your homework in front of somebody if you can. Omega squared equals omega naught squared plus 2 alpha theta. So when people see you solving homework problems with omegas and alphas and thetas, they think you're doing some very impressive work here. And really, it's just straightforward kinematics. We learned it all already. It's the same equations, just in a different form, because right now we're talking about rotational motion. Now that's rotational kinematics. The next thing we get into is dynamics. So when we did linear motion, linear kinematics, that was like chapters 2 and 3, 1 and 2 dimensional kinematics. And then we got to chapter 4, which introduced forces. Dynamics is what goes on when you get into forces. We know that things move and we can describe the motion, but now we have the tools to understand why something is moving. And so Newton's laws, Newton's second law is the force equals ma law. According to Newton's second law, a net force causes an object to have acceleration. But what causes an object to have angular acceleration? It's a different thing, slightly, maybe. But the thing that causes angular acceleration is torque. We will have more Greek letters because what possibly is wrong with having lots of Greek letters? The Greek letter for torque is tau. So it's kind of the funny T looking thing. It's got the kind of squiggly and then the line down. Tau, T-A-U. That's torque that causes angular acceleration. Now, if you're thinking ahead, angular acceleration alpha is a thing, but since force equals mass times acceleration, torque equals angular mass times angular acceleration. What the heck is angular mass? And is it different than just regular mass? And it is. So hang in there. We will talk about that in just a second. If you haven't really thought about torque, torque we most commonly experience by applying a linear force and having that result in an angular acceleration. So I always think about going to the mall, which maybe not a lot of us have done lately, but when I'm trying to leave the mall, and I hate the mall, so I'm desperate to leave the mall. When I'm trying to leave the mall, I see this big bank of windows, these clear glass doors that lead to the parking lot, and I'm super excited to leave. And then I walk up to this glass door, and sometimes I'm pushing on the door somewhere too close to the hinge. If you've not had that particular experience, anytime you have a door, I mean, it can just be a regular door, you know, in your house, but particularly a door that has the self-closing mechanism on it, try pushing far, you know, at like the doorknob or at the you know, handle area, and you see that it requires a certain amount of force to get the door to rotate. But then try pushing somewhere in closer to the hinges and see how hard you have to push in order to get it to rotate. The thing that causes it to rotate is torque. But what we're going to see here is that torque equals force, and this is a cursive L, force times lever arm. Sometimes we'll see instead of lever arm, it'll just have R, meaning radius, the distance from the axis of rotation, which is maybe even more legitimate. Torque has units of Newton times meters, so no new unit here, but newtons times meters. And the amount of torque is going to be proportional to the magnitude of the force, how hard you're pushing, but also the distance from the axis of rotation that force is being applied. Now, you probably know from trying to open doors in your life that if you push far from the axis of rotation near the doorknob, that's probably the conventional way to do it. Whereas if you push far from the axis of rotation at the doorknob, but actually into the door, that is an ineffective way to try to open a door. If you're like pushing the door harder into its hinges, that's not going to work. So the angle matters, right? So typically our default setting when we think about applying a force to open a door is that our force is perpendicular to the axis of rotation. That's just normal. But if you push at an angle, or perhaps at a crazy angle like this, you're not going to generate the torque. So there is the convention, the understanding that it's only the component of the force that is perpendicular to the axis of rotation that will be generating the torque for you, or in this ankle example, they went ahead and changed the length of the lever arm. Well, since this tendon is attached at 3.6 times 10 to the negative second meters, the effective length of the tendon is going to be shorter than that, or distance of the tendon from the ankle joint is going to be shorter than that by just taking the x-axis component cosine 55 degrees. Either way, we're adjusting for where the amount of torque that is generated. So if a rigid body is in equilibrium, neither its linear motion nor its rotational motion changes. So when I'm sitting here on a chair in my kitchen, there is a force down toward the center of the earth equal to my mass times the acceleration due to gravity. But fortunately, this chair is stable enough that it's able to provide an upward acting normal force equal and opposite to my weight, such that the net force right now is 0. With torque, if something has some reason to rotate in one direction if there is a net torque or a zero net torque. If there's a thing that makes it so that it's not going to rotate, then we get no rotation. It's a net torque of 0. And so that's kind of important for some of our work because we'll be setting up equilibrium situations. Think of a seesaw or teeter-totter down at a park, and you have a big person and a little person on either side of it. If you're both sitting at the extreme ends, the big person's just going to be sitting on the ground and the little person's up in the air. But if you adjust your distance from the axis of rotation, you can find a sweet spot where you're nearly balanced. All right, rigid bodies and equilibrium. Yeah, blah, blah, blah. I don't love this example, so we won't spend a ton of time on it, but just to point out that the diver at the end of the diving board, there is a torque. It's their force, their weight times the lever arm, the distance from the balancing point. And if it's not rotating, if they're able to just stand there, then there's another force. The bolt into the concrete here is providing a downward force equal and opposite, or downward torque equal and opposite to their torque. And you can figure out the forces that are equivalent for each, because torque equals force times lever arm. So force equals torque divided by lever arm. Oh, we won't do the bodybuilder right there. Center of gravity, we mentioned briefly before. It has application with torque because the center of gravity is the point where the net torque is 0, and so something would be balanced. So if I have the ruler that I balance on my finger, and it comes out, that the net torque on this is 0 right now, it's not rotating one way or the other, then I can do force times lever arm on either side, and it should come out to the same value. Whereas if I take a couple of coins and I put them on one side of the ruler, now I have to adjust my center of gravity. I'm way over toward one side because the torque on this side of my finger is now equal to the torque on this side, but torque equals force times lever arm. The force is the weight of the coins. The lever arm is the distance from the axis of rotation. And so I come up with another point where the two are equal. And that gives me a center of gravity. All right. You can overload a plane. You want the center of gravity to be over the wheels, not behind the wheels, such that it rotates and does damage to it. Let me take a quick peek. Take you with me to Canvas page. So one of the great things about chapter 9 is that there's 2 homework questions. So life should be good. What I want to tell you is that torque equals force times lever arm, which you know now. So since torque equals force times lever arm, and here we're given a force and a lever arm, this question is just as easy as you think it might be. Force times lever arm. That's a little bit too easy. Number 7 is maybe a little bit too hard. I don't mean it to be super hard, but it's just kind of a tricky math question. We have 2 children that are balanced on a seesaw. So a child over here, child over here. And we know that one of them has a mass of 20 kilograms. The other one has a mass of 30 kilograms. And we want to find the distance of the smaller child to the pivot point. And the only other information we have is that the total distance between the 2 children, x1 plus x2, equals 3 meters. So this is child 1, child 2, x2 equals. I don't know either of these, the distance for the smaller or the distance for the bigger, but I know that the 2 together add up to 3 meters. Since they are balanced, the net torque equals 0, which means the torque to the left equals the torque to the right. Torque is force times lever arm. So force, 20 kilograms times the acceleration due to gravity times x1 equals torque to the right, 30 kilograms times the acceleration due to gravity times x2. Gravity appears on both sides of the equation, so that can cancel out. So 20x1 equals 30x2. I have one equation with 2 unknowns. That's a bad day. I don't know how to get the answer to either of these based on this equation. 20x1 plus 30 equals 30x2. I can't even guess what x1 and x2 are. I need another equation, which I have. x1 plus x2 equals 3 meters. Those are x's. So what does that do for me? Well, I'm going to solve this equation for x2. x2 equals 3 meters minus x1. And then I'm going to plug that in to the equation here in place of x2. So bringing all of this up here, 20x1 equals 30 times 3 minus x1. I've taken one equation with 2 unknowns and turned it into one equation with 1 unknown. That I can do. That's something we've been doing all along. 20x1 equals 30 times 3, that's 90, minus 30 times x1 minus 30x1. Now I add 30x1 to both sides of the equation. I get 50x1 equals 90. So x1 equals 90 divided by 50. If I could do that in my head, that'd be awesome. 90 divided by 50 is 1.8 meters. So since the total distance between the 2 children is 3 meters, the smaller child is 1.8 meters away, the larger child is 1.2 meters away. That makes sense, right? Because the smaller one, the lighter one, has to be further away to have the same amount of torque as the heavier one, more massive one, 1.2 meters away from the axis of rotation. So the quiz 1 week from Friday on chapters 8 and 9 material has 3 questions from chapter 8 material. So we'll go over those homework problems for sure next Friday. But also 2 questions from chapter 9 material, and chapter 9 material only has 2 questions on it. We just went over kind of both of them, but definitely went over one of them. So you should be in okay shape for that quiz. Clear all drawings. Next Wednesday, we will be covering chapter 10 material, which will include this new concept of angular mass. Angular mass we call moment of inertia. So it's like inertia when we talked about the concept of inertia that was embodied in kilograms, but moment of inertia has to do with how that mass is distributed around the axis of rotation, and we will move from angular kinematics into angular dynamics next Wednesday. And that's it for material for the course. If you look at our Canvas page, let me take us back there. You will see that I have updated it to at the bottom. Exam 2 is on Friday, April 30th. So the practice exam is here along with a video walkthrough of the practice exam. You can take a look at it whenever you feel like, but just so you know, there are some questions that will look very familiar to you right now, because we've covered almost all of the material that will be on the exam. And then there might be a few questions. Here's one with torque in it. Here's one that's using angular kinematics that maybe you haven't thought about yet. Here's one that uses moment of inertia, I of a solid sphere. That's talking about what the moment of inertia is for the bowling ball. So that question you're probably not ready to answer yet because that's chapter 10. Conservation of momentum you should be able to do, ice skaters, another moment of inertia. This one is a net torque, so you can take a look at that. Friction and energy and conservation of momentum in 2 dimensions. The practice exam is longer than the real exam will be. In terms of actual legitimate questions, the real exam tends to be longer because I give you a space to show your work between each question. So the exam looks longer than it really is. But that is where we stand. That's all you need for now. So no class on Friday, no quiz on Friday. I will get your chapter 7 quizzes graded, I promise. And have a nice long weekend, and I will see you next Wednesday. So, see you later.
Professor.
Thank you.
Have a good week.
Thank you.
You're welcome.
Thank you, Professor.
Thank you, Professor.
You're welcome. Have a good day.
I hope you enjoy your day off.
Thank you. Feel like I need it.
I'm sure it's well deserved.
Thank you. Very kind.